All right. So before we get going, a couple things I want to mention. I had the module 8 reading up, but it was under a text header that wasn't published. And so originally you couldn't see it unless you were looking at the assignments tab. So it was up there, but on the home page, it didn't show up. It was up on Top Hat. It was, like I said, under the assignments tab. So just in case that caused confusion for anyone, I kind of have that. I put an announcement yesterday when I realized this, that I extended the due date to be the end of the day today. So if you didn't get that module 8 reading done, now it's the most effective if you look at it before we start covering material in class like today. But if there was any confusion caused by not seeing it on the homepage and having to go to the assignments or go to Top Hat, I wanted to adjust that to kind of accommodate for any confusion that might have caused. Okay. So if you haven't done it, you can get on by the end of the day today, 11:50, and still complete it. Okay. Also, I tried to update the CL points this morning. If you went last night, I'm still waiting to hear back from one of the CL leaders. I think they got their attendance in, but if they're not, they didn't get it in until today since they're relatively late. I'll get those updated again before Thursday's class once I get confirmation that they have all their attendance logged in. But it should be pretty up to date. Okay. Other than that, just kind of a roadmap of where we're going. We're going to have this week, which is going to be specific to consumers. We're going to think about make some connections to stuff that we actually talked about in module 2, just in the light of the perspective of consumers. Next week, we'll focus on producers, focus on their cost structures. We then have spring break. When we come back, we'll have a Tuesday where we just do a review, kind of like the last one, and then the exam is Thursday. Okay? So the exam is only over the last 4 modules. We'll kind of talk a little more about the exam next week, but that's kind of a roadmap of where we're going. Okay? Any questions for me before we kind of dive into material here today? Good? Okay. So I'll be kind of using these slides. I've got a complete version, which I'll post at the end of the week. I put up a skeleton version for you guys. We're missing some of the stuff that was in here. So what we're going to start talking about today is how consumers make decisions. Okay. So we're going to be looking at what we call a budget line or a budget constraint or an income constraint. Okay. So if I was spending all of my income, and we'll kind of keep this at simple 2 good models, if I was buying good X and good Y, the total amount that I could afford using all of my income would be the amount that I'm spending on good X plus the amount I'm spending on good Y. How much money am I spending on both goods? Well, however much I'm buying, the quantity times whatever the price of that good is. Right? So I've got this simple 2 good model where it's the total amount I'm spending on good X, the total amount I'm spending on good Y. If I'm using all of my income, these would be different, combinations I could afford to buy. Okay. So if we think about, in this example, I'm starting out with some prices and an overall income level. So income is 40. We represent income with the letter M. Price of good X is 2. Price of good Y is 5. So I can afford different combinations of good X and Y. What would those combinations look like? Okay. So if I just kind of plug in my prices, and I can even plug in income here, but we'll think about changes in income later. So I'm going to leave that just kind of as M. We can think about how would I visually graph this out? Okay. So we've got some things that are true, but I'll build this out, and we'll kind of hit some of these points along the way. So if I'm buying 2 goods, right? So I've got my X good, I've got my Y good, I've got, what was it? $40, not 20. The price of good X was 2, and the price of good Y, I think I told you was 5. Okay. So if I think about, if I'm only buying good X, how much total could I afford to buy? Well, if I have $40, every unit's going to cost me 5. What's the total amount of good X I could buy if that's all I was buying? Yeah, right. How would you find that value? If I have $40, right, and each unit is costing me $2, the total amount of good X I could afford to buy would be that income divided by the price. Okay. So here I've got what? 20 units of good X. Now, if I'm only buying good Y, how much total can I afford to buy there? Well, it would be my total income divided by by the price of good Y. So here this would be what? 40 over 5 or 8. Okay. So I can find the 2 extreme points when I'm only buying one of those goods. However, I don't just have to buy one. I can buy a combination of these two goods. So if I draw a line that's kind of in between those two intercepts, what this is going to represent, every point on this line is going to be some combination of X and Y I can afford using all of my income, right? Spending all $40. Okay. What does this look similar to? An individual production possibilities curve. If you wanted to, you can think about this as like the individual consumption possibilities curve, right? So these are all the kind of two combinations of these two goods I could afford to buy using all of my income. So any point that's down here, what must be true? If these are all points where I'm using all of my income, any point below that would be where I'm not using all of my income. So they would be affordable, but I'm not using all of my income. Now here, with a production possibilities curve, we're thinking about these firms or economies were using all of their resources. What is a consumer's resource? Income. So every point below that budget constraint, yes, I can afford it, but that related to what we've talked about before, it's almost like for the consumer, these points would be inefficient. Right? I'm not using all of my resources or not all of my income. Now, every point above my budget constraint, these are points that well, if this is a point I can afford, if I keep buying the same amount of X, I can't afford that much of good Y. So all of these points would be what we would say are unattainable, or in terms of consumers, they're unaffordable, right? I don't have enough income to buy that combination of good X and Y, okay? Any questions on that idea? So this looks kind of similar to what we were talking about with individual production possibilities curves. It's just now it's in the context of a consumer, okay? Now, if I wanted to, how do I find the slope of a line? If I've got my Y and X axis, the slope is always rise over run, or here it would be the change in the quantity of good Y divided by a change in the quantity of good X, okay? So here this would give me what? I'm going from 8 to 0, so -8. I'm going from 0 to 20, so my slope would be -0.4, right? If I'm doing math in my head correct here. Any questions on that before we keep moving? Shouldn't be too bad yet. Now, if I remember from the production possibilities curve model, what does the slope tell me? It tells me the cost of good X. So I could almost think about, why is this the cost of good X, right? Well, if I want to buy one more unit of good X, how many units of good Y am I going to need to give up to have the amount of money to be able to buy that? Well, a unit of good X is $2. If every unit of good Y is $5, I'm going to have to give up what? 2 over 5 or 0.4, okay, of units of good Y. So it's still telling us the cost of good X in terms of how much of the other good do I have to give up? Same as our production possibilities curve, okay? It's just now it's in terms of consumption, okay? So any questions over this? So why is it downward sloping? Well, if I want to buy more of X and I'm currently using all of my income, what do I have to do? We said if I want to buy more of good X, I'm going to have to give up some of how much of good Y I'm buying, okay? So that's kind of our general setup, right? I think I have the goods here. I'm thinking about buying pizza and Pepsi. So if I go and I'm only buying pizza and I can, get 8 slices, but I have nothing to drink, well, maybe I want something to drink. I'm going to have to give up some of those slices of pizza that I was buying to have the money to buy that first can of Pepsi or whatever it is. Okay. So there's this trade-off. As I want to have more of one good, I have to give up some of the other. So we have this kind of negative sloping budget constraint. Okay. And then we talked about those different ranges: unaffordable, affordable using all of my income, and affordable, but I'm not using all of my income. Okay. So let's instead kind of work through an example with some different values, right? And we'll kind of run with this one for the next 20, 30 minutes. So let's say I'm trying to reinvent my image and I'm only wanting to buy flannel shirts and cans of PBR, right? So I've got 2 goods. I've got $200 to spend. That's my income. And I've got the price of both goods, okay? So if I wanted to kind of construct this model, and I'm going to put flannel shirts on my X-axis, okay? So once again, we can do a similar thing. It's just now I have an actual name for these goods. So I had flannel shirts on my x-axis, PBR on my y-axis. My income is $200. Price of a flannel shirt, I think I was told, was 20, and these cans of PBR are 5. So once again, how would I find, if I'm only buying flannel shirts, how many total can I afford to buy? Well, I've got $200. If each one costs me $20, how many total can I buy? 10. Right? I just take the amount of income I have divided by the price of that good, and that's the total amount I can afford. Now, if I was thinking about the other good, if I'm only buying that good, how much can I afford to buy? Well, I've got $200. The price of that good is 5, so I can afford to buy 40 units of that good, if that's all I'm buying. Now, I can also afford to buy different combinations of those two goods. Okay? So kind of later on, we'll talk about what that looks like, how I would determine some of these points. Okay? But this is the general setup. All right? Now, how would I find my slope? That's just the change in the quantity of my Y good over the change in the quantity of my X good. So here those values are what? It's going from 40 to 0. And my x-axis good is going from 0 to 10. So I have this slope of -4. So how can we interpret this slope? Well, it's always going to be the cost of my x-axis good. So that means every time I want to buy one more unit of good X, how many units of good Y am I going to have to give up? 4. Or the thought experiment here is, if I want to buy one more flannel shirt, how much is that going to cost me? Well, whatever the price is, right? So I would need $20, right? So I could almost think about, what if I started here? I was only buying cans of PBR. If I want to get that first flannel shirt, I need $20. So how much of that Y-axis good am I going to have to give up? Well, if each unit of good Y cost me $5, to get that $20, I would need to give up 4 cans of PBR. Or essentially, I'd be at a point of 136 on that consumption curve or on my budget constraint. Now I could start to do this thought experiment for any quantity of good X here that I want, or any quantity of flannel shirts. But that's the idea. The slope is telling me to get one more unit of good X, I'm going to have to give up that many units of good Y, because I need to get the money from somewhere, right? And we're assuming any point on this line, I was using all of my income. Okay? Any questions on this idea before we keep moving here? Okay with that? Okay, so we go back to the slides real quick, and then I'll kind of jump back to thinking about how we would solve this. So we kind of set up this model where I was using my income and the prices of these two goods. I could calculate my slope. Now, in a second here, I'll kind of show you there's another equation we could calculate the slope using. We don't just have to use quantities. And I'll kind of show us why in a second. So for right now, we'll kind of skip this idea of the relative price. If I'm thinking about 3 points here, what would point C represent? A point that I can't afford, right? These are the points I can afford using all of my income. Any points past that, I don't have enough money. Point B would be a point that I can afford, right? I'm using all of my income. Point A would be a point that I can afford, but I'm doing what? Not using all of my income. So why is that point of B 8 and 8 on my curve? So let's think about why, okay? So if I wanted to get 8 flannel shirts, where would I be at on my budget constraint or my consumption possibilities curve, if we want to think about it that way? Well, if I want to go from 0 to 8, what's the total amount of money that's going to cost me? So I would take the price of that good times the number of units I want to buy. If the price of a flannel shirt is 20, I want 8 of them. The total amount of money I need to buy 8 flannel shirts is $160. So how much of that Y-axis good am I going to have to give up? Well, if I need $160 and each unit of that Y-axis good is costing me 5, how many do I need to give up? I would take the amount of money I need divided by the price of that good. I would need to give up what? 32 if I do the math here. So to get to that quantity of the x-axis good of 8, I'm going to have to give up, go from 40, give up 32 units. So where would I be at on the curve? A point of 8 and 8. Okay. And I could do this test for any hypothetical point to determine is it on that curve. It's very similar to what we were doing when we were thinking about the production possibilities curve. It's just now we not only have quantities, but we can also think about this in terms of the price of the good, right? How much money do I need to buy this amount of good X? Well, the amount of good Y I'm going to have to give up is however much money I need divided by the price of good Y. Okay. Now, another way of thinking about this is what I kind of glossed over in the slides there. So I can find the slope using my quantities, but I could also think about if I have the exact same model, same two goods, and just as well, we've got it right here, so I don't need to write it out again, right? We had this point of 40 and 10, okay? How did I find these 2 points? It was the amount of income I had over the price of that good, right? The amount of income I had over the price of this good. So when I was using my quantities, right, the change in the quantity of my Y good over the change in the quantity of my X good. So if you just want to think about in general terms, this is what we were doing. Now we found that using the quantities, but what's behind the quantities? Well, to find that quantity of my Y-axis good, this was income over the price of that good. To find the change in my X-axis good, that was my income over the quantity of that good. Now notice what happens here if I do some algebra. If I've got M in both numerators, what happens when I divide this? They would cancel out, right? If I now have 1 over the price of PBR or my X-axis good, 1 over the price of a flannel shirt or my X-axis good, notice this becomes my relative prices. Now, technically, right, there's always a negative sign here since it's downward sloping. Or in general, I've got specific goods here, but what does this represent? The price of the X good over the price of my Y good. So I can always find the slope if I don't have the quantities, if I was only given prices, it'll always be that relative price of those two goods. Because behind the scenes, how was I finding these quantities? It was my income divided by the price of that good. The prices were really existing behind the scenes. Now, this is where it gets a little bit tricky, but hopefully I can prove to you why this is the case. If I use my relative prices here, what was the price of a flannel shirt? 20. What was the price of PBR? 5. Sure enough, if I use the quantities or the relative price, I get the exact same slope. Okay? And that'll always be the case. Right? And this is the algebra that proves it. Now, this is where it's a little bit tough because it's counterintuitive. Right? It's kind of like elasticities. Right? When I'm calculating the slope and I'm graphing out the different quantities of these two goods I can buy, it's the way we would typically think about it. Rise over run is the change in the quantity of Y over the change in the quantity of X. But when I'm using the prices, it gets flipped, right? So it's the relative price of good X to the price of good Y. X goes on top. So just like elasticities, that kind of result, it's counterintuitive. Okay. Now, maybe a way to remember this is when I'm thinking about the slope represents the what? The cost of my X-axis good. So it's always going to be the price of the X-axis good relative to the price of my Y-axis good. Or think about it this way. For every 1 unit of good X, how many units of good Y did I have to give up? 4, which was that relative price. If I need $20 to buy a flannel shirt and a can of PBR costs me 5, I need to give up 4 cans of PBR. Right? It's that slope is representing the cost of 1 more of that X-axis good. Okay? Excuse me. Any Questions on that before we keep moving? Okay with this? Okay. So we'll talk through the intuition here, and then we'll kind of model these out. So let's say I've got my budget constraint, and I have a change in my income. If I have an increase in my income, if I'm only buying X, can I buy more or less than before? If you have more money, you're only buying one good, I can now afford to buy more of that good. If I'm only buying Y and I have more money or income goes up, I can now afford to buy more of the Y good. So both my intercepts are going to change. Now, if I only had a change in income, my prices have stayed the same. So when we calculate the slope using relative prices, what's happened to the slope of my budget constraint? Hasn't changed at all. So if I have changes in income, what am I going to see? A shift in my budget constraint, but it's going to be a parallel shift. The slope is still the same. Now, if instead I think about what if I have a price change, right? So we'll kind of work through a model like this, but let's say I have I think the way I did it in the next example, let's say the price of a good goes down. With the same amount of income, if I'm only buying that good, can I buy more or less than before? More. I have the same amount of money. It costs less per unit. I can buy more units. Now, for the other good that didn't experience a price change, if I only buy that good, how much more or less can I afford to buy? Same amount, right? The price is the same. I've got the same amount of income. So we're going to see not a kind of shift out. We're going to see kind of this change. Well, one of the prices changed. If the slope is my relative prices, I'm going to see a change in the slope, right? So we can kind of think about what this is going to look like, okay? So I think on the slides, I originally gave you an example. Let me just make sure I'm getting the values correct here, right? So we'll work through an income change first. I don't think it's too bad. So originally, we had this model where here were the two goods I was buying. Our income started out at 200. Price of a flannel shirt was 20. PBR was, I ran out of room, but it's 5. Okay. So we had here, if I use those quantities, or I use my relative prices, so the price of my x-axis good was 20, price of the y-axis good was 5. I could also use the quantities and come up with that slope of -4. Okay. Now, if I have more income, so let's say my income goes up to 300. If I'm only buying the x-axis good, how much can I now afford to buy? My total income divided by the price of that good. So 300 over 20 would give me a quantity of 15. What if I'm only buying the y-axis good? Well, I now have $300. The price is 5, right? So I can now afford to buy 60, if I'm doing math in my head correct there. So what have I seen? I've seen that my income constraint or my budget constraint has went up. Now, what is the slope if I have a change in income? Still the relative prices, so still 20 over 5, right? So with income increases, I kind of see this increase in my budget constraint, which means what? Every point here used to be what for my old budget constraint? Unattainable, or what we now say for consumers is unaffordable. With my new budget constraint with higher income, I now can afford those points. And in fact, these points, I can not only afford them, I don't even have to use all of my income. Excuse me. So an income increase is going to shift that budget constraint out. What do you think an income decrease is going to do? Shift it inward, meaning there were points I used to be able to afford that I no longer can, right? But no change in my slope. The prices haven't changed at all, okay? Now, what if instead I had that same kind of original example? So I'm thinking about here, I had 40 and 10, and my original slope was -4, right? That was my relative price of the x-axis good compared to the price of my y-axis good. Okay. Let's now assume that the price of a flannel shirt goes down to 10. Now, right away, I should think about, if I see a change in the price of a flannel shirt, what should I be shifting? The quantity of flannel shirts should go in one of those two directions. If I have the same amount of income and the price of the good is lower, I should be able to afford to buy more. For the good that didn't experience the price change, I have the same amount of income, its price is the same, I can afford to buy the exact same amount. Right? So my new budget constraint is going to look something like this. Well, what's the new amount of good good X I can afford to buy? My income, which was originally $200, divided by the new price of that good, which is 10, I can now afford to buy 20. So if I use my quantities, the change in the quantity of my Y good over the change in the quantity of my X good, it's now going to be what? 40 over 20 or -2. If instead I use my prices, it's going to be the price of a flannel shirt. I don't know why I had a P in there. Sorry. Flannel shirt divided by the price of the y-axis good. So now this would be what? -10 over 5, or sure enough, if I use quantities or prices, I get the same value for my new slope. So when the change in the price of one good happens, it's going to not to shift the entire curve, it's going to change its slope. Now, intuitively, if the price of one good is lower, there are going to be combinations of those two goods that I used to not be able to afford that I now can. Right? And then we could also do price increases, right, which would look a little bit different, but we can kind of think through these models here in a second. This would be what a price increase looks like. Or sorry, this is what a price decrease looks like. We can then think about what a price increase looks like. Yeah, that was going to be one of my next questions. What does this change look like when we compare it to module 2? It looks like a technology change. Because what did the technology change do? It lowered the cost of production. What is the cost of consumption? My price of the good. So when the price of that good goes down, the cost of consumption is now lower. That relative price, or the cost of my x-axis good, has went down. That was a price decrease. Any questions over this before we keep moving here? Now I'll draw one more thing out for you, right? So we can kind of think about just kind of covering our bases here. Let me see where we're at on time. So I want to go, okay, perfect. So let's instead think about, I'm starting out with my original example, right? So I have income is 200, price of a flannel shirt was 20, and price of PBR was 5, right? So I started out 40, 10. I had a slope of -4. Whether or not I used my, where is it at? Relative price, or if I used my quantities, okay? Now let's assume instead now, and we'll do the other good. Let's say the price of a can of PBR goes up to where it's now $10, okay? So first of all, I had a change in the price of which good? My y-axis good. So I should be thinking about that intercept is going to change. Now, does it go up or down? How do I find, and sorry, that's a 4, right? How do I find my new intercept for this y-axis good? It's the amount of income I have divided by the price of that good, which would now be what? 200 over 10. So when prices go up, can I afford to buy more or less than I was before? Less. So this new value would be 20. If I'm only buying flannel shirts, the price is the same, my income is the same, I can keep buying the same amount. So when I have a price increase in one of those goods, it's going to shift my budget constraint down, but not a parallel shift, right? It's going to look like I had not a technology improvement, but like a technology devolvement, right? Or maybe lower pop, whatever it is, right? I have fewer resources, right? And that's because even given the same income, if the price of that good is now higher, I can't buy as much as before, right? So it used to be all these points here used to be points I could afford, and I wasn't even using all of my income. Those points are now going to be what? If they're above my budget constraint, I can't afford them, right? So now if we wanted to calculate my new slope, I could use the change in the quantity of my Y good over the change in the quantity of my X good. Or we said, and here it's going to end up being negative, we could also look at the relative prices. So if I use my quantities, what's the change in the quantity of Y? It's going down by 20. What's the change in X? It's going up by 10. Sure enough, I get this slope of -2. Right? Now, if I look at my relative prices, what's the price of my X-axis good? It's still 20, but the cost of my Y-axis good is now 10. Whether I use the quantity or the price, I get that exact same slope. So I can do any combination here. Price increase or decreases in the X good, or price increases or decreases in the Y. Right? Or I can have a change in income, right? That causes our nice parallel shifts. So any questions on anything here before we keep moving? We're okay with this? Okay. So now think about something a little bit more difficult. So that was something that wasn't in the slides. So that's where we're coming to class, seeing we draw these out. I gave you in the slides the price decrease in the X good. We just went through the exact opposite, which was a price increase in my Y good. Okay. Now let's think about these hypothetical kind of budget constraints. Let's say the original budget constraint is this black line. So intuitively, any one of these lines must represent a change in what? Well, if I have higher combinations of these two goods I can afford, I either must have more income or the prices of those goods must have went down. So if I move from the black line, my original budget constraint, to A, it must be that I have more income. It changed the amount of both goods I could buy if that was the only two goods the only good I was buying of the two. Now I can also afford different combinations of these goods that used to be unaffordable. Now, what would moving to line B represent? Well, if I'm only buying the Y good, I can keep buying the same amount. So I don't have a change in my income, I don't have a change in the price of that good. If I move to point B, what would that represent? I have the same income, but now the price of X went down. I could afford to buy more. Right? That was one that we kind of drew out already. Now, what would moving from the black line to line C for the green line represent? Well, I can now afford to buy more of the Y-axis good, but the same amount of X. So it must be that my income didn't change, but I saw the price of my Y good go down. I can now afford to buy more. Now, here's where it gets a little bit tricky. And I'm not going to try to trick you. I'm never going to give you simultaneous changes in both income and price. What I could ask you about is, what's another way? Let's say my income didn't change. What's another way I could get to that black line to that red line?
Both goods went down.
The prices of both goods went down. Now, if it's a parallel shift, it would have to be that the prices both changed by the exact same, not amount, but the exact same ratio or the exact same percent. So we can see this budget constraint, a parallel shift, could be caused by having more income or a change, or in this case, a decrease in the price of both goods. Now, you could get real tricky and think about what if my income goes up, but the prices of goods also go up? Where could I end up if that was the case? I could end up on that same black line, that same budget constraint. So you think about how these price changes and income changes are going to change our budget constraint. We can think about how we calculate the slope using either quantities or prices. We can also think about how we calculate these intercepts. It was the amount of income over the price of that good. So here's where, let's go here. And I'll give you guys about 7 minutes here. So we'll change this to 17. So I almost predicted this right. And I believe the number is 38.15. Oh, I changed this to 27. Hold on. I wanted that to be 17. So we've got that. Next 7 minutes, I want you guys to work the people around you, work on these 3 questions and have it submitted in 7 minutes at 10:17. I'll kind of give you a prompt as we get closer to that time. But you basically have 3 questions to answer. So kind of start working on those. The first 2 are a little bit tricky, but based off what we talked about, you can solve them. The third is something that should look like what we just went through, so that one shouldn't be as bad. Should be 38.15. Is that getting you everybody in? Someone give me a thumbs up. Yeah, so I'll give you guys the next 6, 7 minutes. Work with the people around you. We'll then kind of come together and talk about these, okay? $38. I said 80 cents. So head down, back and face. If you can afford 40 cents and they have $8. I said, yeah,
31.85.
38. Yeah, I got it. Huh? What error is it giving you? So did you try to go back out to the home page and go back in? All right, just talk to me after class. All right, so you should start wrapping it up here. I've got it set to be due at 10:17, so it needs to be submitted when it says 10:17. So make sure you're kind of getting your answers in there, hitting submit in the next minute. Okay. So we'll start kind of walking through these. I would submit it now because we're not going to get through it by the time that due time passes. Okay. If you don't get it submitted on time, that's going to tell me you were waiting for me to go through the answers. It's not going to be counted if it's late. Okay. So make sure you're hitting submit. We're now going to kind of talk through these. So we'll talk through the last one first. Okay. The first two are a little bit different than what we talked about, but based off what we talked about, we should be able to solve it. Okay. So this one should be, I shouldn't say easy, but we literally just talked about it before I released this quiz. What's the only way we can get to higher indifference curves? Sorry, that's the next topic. How can we get to higher budget constraints? If I have an increase in my income or if prices go down. So if I'm looking at those solutions, what's the only thing that makes sense, right? Well, if I have an increase in prices, what's that going to do to my budget constraint? It's going to decrease it. Everything we had up there was an increase, right? Now, it wasn't parallel shifts, so not all of them are going to represent increases in income, right? But we know it can't be a decrease in my income. Now, what could I see happen? So this is where it's a little, if I saw both the prices go up, that's still going to do what to my budget constraint? Prices are higher, I can afford to buy less. That could give us a parallel shift, but it would still be downward. We said the only thing that increases my budget constraint is more income or lower prices. So here, the only thing that even makes sense, it can't have an increase in price. That would kind of decrease. The only thing that should make sense here is a decrease in the price of good Y. I can now afford to buy more of good Y, same amount of good X. So we said line C was representing a price decrease in Y. Okay. It was literally one of the things we just went through. Now, the other ones are a little bit tougher, but everything we talked about, we could kind of get to, okay? So here I'm giving you an income of $200, and I'm asking you for the price of T. So I kind of have this drawn out. Here was the two intercept values I was given, okay? So if I want the price of T, well, how did I find this point? It was the amount of income I had divided by the price of the good I'm looking at. So if this is equal to 50, I was told my total income was 20. It's just a little bit of algebra here, right? Multiply both sides by the price of T, divide both sides by 50. Now I end up with what? The price of T is 200 over 50, or it must be $4. Okay. Any questions on that idea? Now, just to kind of make a point, what would the slope be here? It must be 50 over 80. I can still use those quantities. Okay. Now, in the second problem, I had Now I forgot what it was. I believe I asked you, I told you the price of, what did I do? I told you the price of tea was equal to $2, but I didn't give you income. Okay. And I then asked you about what's the price of coffee. Okay. Now you could do this two ways, right? I think the easier way is to remember, okay, my slope, right, is going to be the relative price of my x-axis good to the price of my y-axis good. Well, I only know one of these two things. I have the price of coffee over 2 now. What's another way I could find this slope? The change in the quantity of my y good over the change in the quantity of my x good. So here, what is my slope? 40 over 100, or negative 0.4. Technically, there's a negative sign in front of here. So if I know my slope is 0.4, I know I could also get my slope by taking the price of the x good over the price of my y good, which I was told was 2. A little bit of algebra here tells me the price of coffee must be 0.8. Now, what could have I also done? I could kind of do a similar thing where if I could only afford to buy tea, or if I, sorry, not only afford, if I am only buying tea, well, if I know the quantity is 40, I know that's my income over the price. I was told the price is 2. So what must my income be? 80, right? If my income is 80, and I'm buying 100 units of coffee, I could do a little bit of algebra here. Hold on, what did I have here? So I did 100 price. What did I do with my income? Did I mess up a value here? Yeah, this, oh no, this is 80. Oh, sure enough, right? I end up with, what's the price of coffee here? A little bit of algebra, 80 over 100 gives me negative 8 because it's a slope, but I have a negative sign in front of here. So it gives me that same value of 0.8. So I think that way is a little more convoluted. It's probably easier to remember my slope is the relative prices. If I know one of those prices, I can use the quantity to find that slope and then back out what the other price must have been. Okay. So kind of two ways of solving that one. Any questions over any of those? Okay with that? So this is where I'm not always going to put the quizzes at the end of the class. That's why kind of being here all of class might be important. Okay. Also, we're going to cover other material that's good that you know. All right. So we're then going to kind of switch gears a little bit. All right. So we had our budget constraint. We're now going to talk about something called utility. All utility is, another word for it, is the benefit of something. Right. It's the amount of happiness that buying something brings you as a consumer. Right. That's what utility is. Okay. So I can think about, I can buy any combination of goods, right? And the total utility is going to be the total benefit that consumption bundle brings. Now we're going to keep this simple and just look at 2 good models, right? So we're going to just have, I can buy 2 different goods. In reality, we can buy, where we are buying all kinds of goods, right? The math just gets harder. So we're going to kind of constrain this to thinking about 2 good models. And from our consumption of those 2 goods, we're going to have the total amount of utility that we gain from that combination, right? So here's where we're then going to break it down, okay? So my total utility is going to be the overall level of happiness or the total benefit I get from buying these 2 goods. But we don't make decisions based off of totals. We make decisions, the markets did as well, based off of the margin, marginal cost, marginal benefits, marginal utilities. Okay, so the marginal utility is the change in utility. So just like every marginal thing we calculated, if I want marginal utility of good X, it's the change in my total utility I get from good X divided by the change in the number of units that I was buying. Now, a lot of times we'll think about this change in quantity as 1, but it doesn't have to be, right? Sometimes if I think about, this is where my lack of knowledge, I look like a real square. But like, I don't know, whether 12 cigarettes in a pack of cigarettes, I don't know, 10 or 12, right? If I buy a pack of cigarettes, I'm buying 12, but my quantity isn't 1, it's actually 12, or however, think about things that you buy in bundles, okay? So here I'm going to get rid of this marginal utility column for a second. So let's say I give you these different quantities of a good. I then give you kind of what the total utility is. Okay? So as I buy more of something, what has to happen to my total utility? If I'm buying it, it must be that it was bringing me some level of happiness. So if I buy more of a good, it's going to increase my total utility, right? So as I buy more of this good, I'm always seeing total utility go up. But what did we say is happening with the demand curve? As I buy more of something, what was happening to my marginal benefit? It was going down. Benefit and utility, you can think about really synonymous terms. So as I buy more of something, what should be happening to my marginal utility? It should be decreasing. I think about this like in the context of if I'm making a choice. So there's a website and I'm wanting to buy a watch. They've got 50 different color, whatever combinations. Which one am I going to buy first? The one that increases my utility the most. Now I bought that one because I like it the most. If I have enough money and I buy a second one, which one am I going to choose second? The one I liked the second most, or brought me the second highest margin utility. Then which one am I going to buy third? The one I like the third most, next highest margin utility. So my margin utility as I buy more of this same good, it's going to go down. Or think about this like the first car I buy is one that if I had all prices of cars the same, brings me the highest level of margin utility. Right? I then buy the next one, it's a little bit lower, otherwise I would have bought it first. Now, how do I calculate my margin utility? It's just the change in my total utility divided by a change in quantity. So here, what's the margin utility of that first 5 units I buy? Well, what was the change in total utility? 60, that's not my margin utility. Because that's the change in my utility, but how many units did I have to buy to get that? 5. So the amount of additional utility I was getting per unit would be 60 over 5. All right. So that would give me what? 15? Nope. Sorry, not 15. 60 over 5 should be what? Well, there we go. 12. I'm trying to work backwards. And then what's the next margin utility? Going from 5 to 10, the change was 45. In total utility, the change in the quantity was 5, so I would get 9. And then so on and so forth. So as I buy more of this good, my total utility is always going up. But what's happening to my margin utility? It's decreasing. Okay. So visually, what would this look like? Something like this. Here's my total utility curve. As I buy more of this good, total utility is always increasing. The slope is positive. But what's happening to my slope? It's getting flatter and flatter. So when I calculate these margin utilities, the change in total utility here was 10. Here I kept the quantities nice and easy. It was going from 0 to 1, so the change in quantity was 1. Then it goes from 10 to 5, divided by the change in quantity of 1. So 10, 5, should be an 18 there, 3, and 2, so on and so forth. So what does this look kind of similar to? Module 2, this was our per worker production function, right? So here I don't have a linear slope, right? It's changing. So I've got my total utility. It's always increasing, but it's increasing at a what? Decreasing rate, right? So I could graph this out and plot my margin utilities if I wanted to, just to kind of conceptually. I'm not going to make you do this, but the next level, how do I find the slope of a line? If it's linear, rise over run, and technically if it's not linear, I can still do that. But if I want to find the slope of a line of a function at any point, I would take if you're in Kelly, you should know how to find the slope of a function. You would take starts with a D, derivative, right? I'm not going to make you do that, but that would be kind of the next step or the next level. So what we can do is think about if I had my total utility function, instead of taking that derivative to kind of make this a little bit easier, right? I had my total utility function look something like this, right? So I had 1, 10, quantity of 2, 15. I'll stop at a quantity of 3. This was 18. So if I instead, I want to kind of map this out, just like we did the per worker production function, we kind of map out like the marginal return to capital. My marginal utility would be at that quantity of 1. The change in my utility over the change in quantity was 10. Here, going from 1 to 2, the change in my margin utility for that second unit was only 5. For the third, that change was 3, right? So what's true about my margin utility? it's decreasing as I buy more of that good. Just like the demand. It was our marginal benefit as we bought more of something, it was decreasing. Benefit, utility means happiness. It's really synonymous. It means the same thing. Okay. So as I buy more of something, total utility is going up, but it's doing so at a lower rate. The change in my total utility is going down as I buy more of something. Okay. Any questions on this idea before we keep moving? We're okay with this? So we're going to use this in the discussion next. So here's where try to give you a little more real world context, and we'll talk through some of these issues. Okay. So let's say I had an infinite amount of resources. I have all the income in the world, Elon Musk. If I can afford to buy anything, as long as the marginal benefit is positive, I'm going to choose to buy it. Or if my marginal utility is positive, I'm going to buy that good. Right? So technically, if I had all, income is there is no income constraint. I'm just going to buy something as long as that marginal benefit or marginal utility is positive. Now, the problem is in the real world, we all face, even Elon Musk technically has a limited amount of resources. It stops somewhere. So I can't just buy more of everything. So what am I going to want to start to buy first? Whatever would bring me the highest marginal utility. Now we'll throw a caveat onto this in a second, because what would bring me a really high level of marginal utility? A multi-million-dollar house on the ocean. Why don't I go buy that? I am constrained by my income given the price of that good, right? So even though it would provide me with a really high level of marginal utility, I have to factor in prices, right? So we've got a certain amount of income. We've got prices. We can't get to, we can't buy whatever brings the highest marginal utility because it's going to cost us something. So what we end up thinking about is what's the optimal consumption bundle? And once again, we'll keep it at simple 2 good models, but you could model this with thousands of goods. We want to buy whatever has the highest margin utility per dollar we spend, right? So we want to kind of scale this to be the additional utility I'm getting per dollar I'm spending, okay? So the consumer's decision, did I not have it built in here? I've got another slide in a second. I want to buy whatever brings me the highest margin utility per dollar I'm spending, okay? That's going to be the optimal consumption bundle, or you can think about this as like, what's giving the most bang for my buck, right? What's providing me the highest amount of additional happiness per dollar I'm spending, okay? So I have kind of here, I'm hitting the arrows in the wrong way. We're going to end up, and I'll kind of give you the end result and then give you some reasoning as behind why. So we know that I'm giving you right now the definition of where your optimal consumption bundle is where the margin utility per dollar you're spending on both goods should be exactly the same. Now we'll think why this is the case. Okay, so I'll give you some reasoning. Hopefully that supports why this is what it is. Okay, so here if I'm thinking about, I'm telling you that we should be making decisions based off of the marginal utility per dollar we're spending on both goods. Let's do a thought experiment. Let's say the margin utility per dollar is higher for good X. Well, if I'm getting more additional happiness from every dollar I'm spending on good X, what do I want to do? Buy more of good X. And I shouldn't say the problem is, but a result of that is that if I buy more of good X, what's happening to the margin utility I'm getting of good X? It's going down, right? So if it's going down, what's happening to my fraction? It's going down. Eventually, if I keep buying good X, what could happen? I could see that this flips, right? In which case, now what do I want to do? Buy whatever brings me the highest margin utility per dollar. So I start to buy more of good Y, which does what to the margin utility of the last unit I bought? If I buy more of something, the margin utility of the last unit is going to be lower. So I would kind of have this back and forth until, right, I end up at a point where these are equal to each other, in which case, should I buy more or less of good X or Y? they both give me the same amount of additional utility per dollar, I stop here. Because if I buy more of one of them, what is going to happen? The margin utility falls. Now I'm going to want to switch back over to buying more of the other good. So we know that the point where kind of consumers would stop making this switch or this decision to buy more or less of one good will be when the margin utility per dollar are exactly the same, given the current quantities I'm buying of these two goods. Okay. This is kind of the thought experiment or intuition behind why this ends up being where our total utility is actually maximized. Any questions on this idea before we keep moving? So with this idea in mind, we kind of have this weird thing that happens in the real world. And we'll kind of use this concept and talk through this, right? So we call it the paradox of value, which is the idea that total utility and margin utilities don't always align. So if I think about the total utility I get, let's say I'm looking at water and diamonds. If I buy a diamond, what's the margin utility? Sorry, what's the margin utility? It's going to be relatively high. What's the margin utility of each drink of water that you do or have? Really, really small. But what's the total utility? Well, if I'm buying diamonds, how many diamonds do most people own? One or two, couple. So the total utility, even though the margin utility was high, the total utility is going to be about the same, the margin utility. I only have one or two. But even though the margin utility of every drink of water is relatively low, how many bottles of water, how much water do you buy to shower? How much? A lot. Even though the margin utility is low, if I buy a lot of that good, what happens to my total utility? It's going to be really high. Over the course of your life, your total utility you get from consuming water is going to be way higher than the total utility you get from buying diamonds. And that's because you buy a lot of water. And which is not just about drinking it, but right, once you have a home or apartment, right, you have a water bill, you're paying over your life for a lot of water. What's the additional utility for every unit? Pretty small. When we're thinking about total utility, it's the marginal utility we get per unit times the number of units we're buying. In fact, right, not only does the marginal utility matter, but prices matter. Even though the marginal utility of water is relatively small, if I buy more of whatever gives me a higher margin utility per dollar, we've got to factor in prices. So I'll give you an extreme example just to kind of prove this idea and maybe kind of put it in the context of my life, right? So if I'm thinking about buying things, when the margin utility per dollar I'm spending, I want to buy the thing that has a higher margin utility per dollar. Let's say the margin utility of additional diamond is like really, really high. What's also true about the price of a diamond? It's really, really high. So maybe I start out here where the margin utility per dollar I'm getting is 1. What's the margin utility for every, I don't know, bottle or gallon of water I use? It's going to be really, really small, right? If I could put a value to it, it's going to be a very small number. But if I'm just thinking about water that I drink, if I walk out to that drinking fountain, what's the price of water? 0. I guess technically there was an opportunity cost at the time it took me to walk there. But if I was already walking by it, right, the price is essentially 0. In the limit, if I divide something by 0, what does this become? The margin utility per dollar is always going to be higher for water than it is for diamonds. Now, as I buy more water, that margin utility starts to fall, and technically nothing has a price of 0, right? Once again, we always have an opportunity cost of time, but this would be like an extreme thought experiment about why we see people buy so much more water than they do diamonds, right? In fact, I consume a lot of water. To me, the margin utility per dollar is pretty low for diamonds, so I don't really care about them, right? So how many do I own? 0, right? But this is a kind of thought experiment about why people are making the consumption decisions that they do. Okay. All right. So we've got 10 minutes left. I want to go through a little bit here. So I think I've got some slides here. I'm going to save this till next class. And what I want to do, and I'll bring in next class, and I might even post a file up, just so if you want to work along with me, you can. We're going to start thinking about, if I have marginal utilities and I have income and prices, how do I determine the optimal decision line? Well, we know we should always buy what has a higher margin utility per dollar. We'll walk through a thought experiment about how I determine what my optimal consumption would be, given the margin utilities, given my income, and given price. I'm going to give you an Excel file where we'll kind of work through this, just because I like to do as much as I can. I can't do a lot of it in this class, but I can kind of show you how to look with data. Because you're in the business college, you're going to have to work with data. So I'll bring that Excel example in next class. We'll kind of walk through these. But what I want to go through today is connecting this idea of margin utilities to what we call indifference. Okay. So all an indifference curve is the different combinations of two goods we could buy that give me the same level of total utility. Okay. So it's the different combinations of two goods we buy that gives me the same amount of total utility. Okay. So if I think about my indifference curve here, on my curve gives me the same amount of total utility. So if I want to buy more of this Y good, what do I have to do to keep total utility the same? Well, I know if I buy more of Y, my total utility is going to go up. So to keep total utility the same, when I buy more of Y, I have to buy less of good X. So any point on the same indifference curve is going to be a point that gives us the same level of total utility. Now, what will end up being true, we'll kind of go through in the next slides, but I'm going to draw this out to give you what I think is a slightly better or slightly. So this is where the slides are good. I try to bring some value added to the class when I draw these out. So if I think about, I have the combinations of these two goods I can buy, and let's say I could put a dollar amount to this. So any point on this indifference curve brings me a level of utility or happiness that I say is 100. So units of utility are weird to think about, but let's just say we could assign a value to them. Well, what we're going to end up seeing is higher indifference curves, or moving further away from that 0 point, or what we call the origin, should provide me with higher levels of total utility. So the reason why is because if I think about, if I'm buying the same amount of good X, but I'm buying more of good Y, what has to be true about my total utility? It would have to be, I have the same amount of one good, but more of the other. My total utility would be higher, right? I have the same amount of one good, but more of the other. I know that I must be happier than I was before. As long as the margin utility for that good is positive, which is a safe assumption, right? There are very few goods where the margin utility would be negative. It's technically possible. It'd be a more complicated model than one we're going to look at. For us, we think about having more of something is generally going to increase our utility. Okay. So what we're also going to say is that our indifference curves cannot cross, right? So let's think about why. So let's say I have this indifference curve and I can think about the total utility as 100, right? If my indifference curves crossed, well, what would be true here? Let's say this represents a lower level of total utility because I've got the same amount of good X, but I have less of good Y. So my total utility is lower. Okay, that seems to make sense. So why can't they cross? Well, because if they cross, there's points down here where I have the same amount of good X, but I have more of good Y. So what should be true about this red indifference curve? Over here, it would actually represent higher levels of total utility. So those two things can't be true at the same time. So we can never have these curves cross. So utility curves, as we move further out from that origin or that 0 point, it represents higher levels of total utility, and our curves can never cross. Okay? And this is the thought experiment behind why. Okay. Now, what's going to lead us into next class is the fourth kind of concept or rule we have about indifference curves, which is this idea. Okay. If I have two goods and I'm thinking about the total utility I'm getting from these different consumptions, if I want to keep total utility the same, when I buy more of a good, what's happening? Because I bought more of it, my total utility is going up, which means to keep total utility the same, I have to buy less of the other good. So let's just assume that if I bought one more unit of X, the margin utility is 20. So I would have to figure out how much of the Y good would give me that 20 units of utility that I want to gain by buying one more of the X-axis good. So what's going to end up being true is we can kind of figure out that relative margin utility. So this is going to be how many units, what's the kind of change in margin utility of good X. So what's the additional amount of utility I get from buying one more unit of good X divided by the margin utility that I'm getting from good Y. So the reason why this is the case is we can think about, just like our budget constraint, we can think about how would I calculate my utility constraint. It's not really a constraint, but just to kind of connect to what we already talked about today. The total amount of utility I get from buying these two goods would be the margin utility I get from buying good X times the number of units I get from buying good X. Now, this isn't constant. Technically, there's like a function behind the scenes. We're not going to dive that deep into it. We can just think about the per unit margin utility that I'm getting from all of what I'm buying of good X. Now, to get total utility, I would also add into that, well, what's the additional utility I get from every unit of good Y times, I'm talking and writing, sorry, the quantity of good Y that I'm buying. Okay. So if I had, this is my total utility, or this is my indifference curve. All these different combinations of good X and Y provide me the same amount of total utility. If I do a little bit of math here, so let's say I subtract this from both sides. I rearrange things a little bit. I've got the margin utility of Y times the quantity of good Y would now be equal to my total utility minus the margin utility of X times the quantity of good X. So I'm just doing a little bit of algebra. The next level of algebra I'm going to do is I'm going to divide both sides by the margin utility of good Y. It'll make more sense why I'm doing this in a second. I'll kind of tell you why. So what am I left with? The quantity of good Y is equal to this minus the margin utility of X over the margin utility of good Y times the quantity of good X. So I've just done algebra here. But I now have a function that is what? Whatever is on my Y-axis as a function of what's on my X-axis. Or essentially, I've got Y, here's my intercept, here's my slope, like the kind of general, I guess technically, we're adding B is negative here, but I basically just have the slope of a line. I have the Y value as a function of my X value, right? So what is the slope of this indifference curve, right? It's going to be the relative margin utilities, okay? So that's why the slope of our total utility curve or our indifference curve will be the margin utility of X over the margin utility of Y. I just did the algebra to kind of prove that's why it is what it is. So what we're going to do next class is say, okay, we face this budget constraint. We want to know, I'm trying to figure out what is the optimal amount of these two goods that I can buy. We said what should be true is the margin utility per dollar should be the same for both. So I'm facing this budget constraint, and I want to get to the highest level of total utility, right? If money wasn't an option, I keep buying more of both goods and get to these higher indifference curves. But there's going to be a budget constraint, all right? So we'll talk through next class, how do I combine those two things to figure out where that optimal consumption bundle is going to be. I'll use that Excel example, so you might see me post a little Excel file up there of the modulated materials. We'll break down things into the price and, income and substitution effect. Other than that, see you guys. Try to stay dry, and I'll see you on Thursday. One second.